So should we start on time or give people a minute or more?
Yes, just go ahead.
Okay, then we start. This is TCPM. We have 3 co-chairs, Yoshifumi, Michael Scharf, and myself. I'm moderating on this meeting this time. You should have seen the note well, at least when you registered for the IETF, so we are bound to these rules. Logistics, we have a note taker. Gori agreed to do this. Thank you very much for doing this again. A JavaScribe is Michael Scharf, at least when he's not presenting. So if there are comments during his presentation, maybe someone else can put the stuff in. But as far as I know, this is also reflected in the chat in Meet Eco. If you want to submit a draft which is of interest of this working group, please include TCPM in the name, so it's simpler for us to find these documents then. As usual, this session is being recorded, so whatever you say, or if you turn on your camera, this is recorded. And for the presenters, Meet Eco has a feature where we can upload the slides to the tool, which has been done. And so you can run your own slides. So if you want to do that, you can do that. If not, Yoshi will run the slides. This is the agenda for today. Working group status update. And then we have 4 presentations. All on working group documents, mainly status updates. The documents are in various states, as we will see here. So we have done or finished our work on 2 documents since the last IETF. The 2940 BIS document is in the RFC editor queue. It will be RFC 9040. And the 793 BIS is in the ISG last call. So these documents are at least almost done by the from the perspective of the working group. We have a milestone. The next document, which is an update of PRR, which hasn't changed since the last IETF, and we don't have a presentation this time. So we hope that at least we get a presentation at least by the next IETF. The next 4 milestones we have covered by presentations. The RFC 8312 BIS document is actually in or after working group last call. So the working group last call was started and we haven't formally closed it, but we will see, we'll get a presentation on the changes which have been made due to the comments on last call, and this is your last chance to provide comments. And the other documents are still being worked on. The last 3 documents with milestones end of this year or later, we don't have presentations on, but these documents still have some time to be worked on. Yeah, that's the status of the documents. Any questions, comments? If that's not the case, then we can move on to our first presentation, HiStart++, Praveen.
Can you hear me all right?
Yep. So you can upload your slides by this document icon on the top left.
I sent in a slides request.
You sent in a slide request. Ah, yep.
Okay, I hope you can see the slides now.
Yes, perfect. Go ahead.
Okay, hello everyone. Today I'm going to be talking about HiStart++, particularly some recent work we have done to add jitter resiliency to this algorithm. This is the work done with Yi and Matt, but I'm going to be presenting today. So a quick recap of what is HiStart++. The original motivation for this algorithm was that standard slow start as described in RFC 5681 can overshoot the ideal send rate, sometimes as much as by 2x, and can cause massive packet loss. It basically results in the connection spending a bunch of time in recovery. Sometimes results in RTO if you're not able to recover from those losses, even though with RAC and TLP recovery is now improved, we still see cases where we would end up with an RTO. This basically means impaired flow completion times as well as unnecessary retransmission sent on the network. So until draft 01, it was a simple modification to slow start. The delay increase algorithm from the original HiStart paper was used to trigger an early exit from slow start when basically we detect that the delay is increasing due to the bottleneck buffer filling up. But because that sometimes this would cause a premature exit, we would compensate for that by introducing something called as limited slow start, which still grows the congestion window faster than congestion avoidance, particularly because even with cubic, the ramp up would take some time. So we were basically, we defined the constants and we provided some guidance on tuning this. This algorithm got implemented in multiple places, not just the Windows TCP/IP stack. So, but we have jitter problems. So there's one particular use case where we noticed internally that HiStart++ was leading to suboptimal performance, which was basically there would be latency spikes in WAN transfers that would trigger HiStart, and immediately after we would exit slow start, the latency spike would go down. We could determine that this latency spike was happening as a result of cross traffic, but before we could fully root cause the problem, it actually ended up disappearing. We might have to go back and look at why this was happening, but it was pretty consistent for at least a week or so. There are other reports of problems, performance problems due to HiStart, particularly on LTE networks. There was one presentation in MapRG last year which talked about the performance being not good for mobile radio networks. This was also raised an issue by Kristen in the TCPM mailing list. And there's also like a paper about poor HiStart performance over a satellite network that was presented in the NetDev conference, I think just last week. So as a result of this, we started looking into how we can make the algorithm better in presence of jitter. Our sort of key insight here is that instead of trying to compensate for premature exit, why don't we spend a little bit more time to determine if the exit from the slow start is correct or is spurious? So effectively, the change to the algorithm is that once we trigger the exit from slow start, we enter a conservative slow start phase. The goal of the conservative slow start phase is to still grow the congestion window, not as aggressively as slow start, because obviously that goes back to the original problem of overshoot. Grow the congestion window slower than original slow start, basically as a fraction of what standard slow start would have done. And then we measure whether the RTT shrinks anytime during this phase. If the RTT shrinks, the exit was spurious, and we effectively resume HiStart++, which means we go back to doing standard slow start and including the whole algorithm from the beginning, which continues to measure if there's further delay spikes. If we determine that the RTT does not shrink during this phase, we enter congestion avoidance. So that basically confirms that the exit was not spurious. The RTT is continuing to remain high. So again, the key rationale here is that instead of trying to compensate, we are basically trying to make the algorithm effectively determine if exit from slow start is spurious or not. So these are the details of the algorithm. So in standard slow start, we update the congestion window as per the RFC 5681. We continue to measure min RTT for each round. So rounds are measured using a sequence number technique, which we document in the draft. In each round, we basically measure remember the last round's min RTT, and if sufficient number of rounds have passed, which is like a threshold a parameter, which can be experimented with, we basically, and also at least n RTT samples are taken in that round, then we check if the current round's min RTT is greater than the last round, plus a threshold. So the threshold is basically capped at both the minimum and the maximum. There's some discussion on this that I'll bring up in the last slide. There's a new change to the algorithm now. So when we do exit slow start, we now take a baseline measurement for the conservative slow start phase. So basically at the round where we exit slow start, we snapshot the current round's min RTT. The conservative slow start phase lasts a few rounds. Currently, per the draft, the recommendation is between 4 and 5. The reason it's not a fixed number here is because it could be triggered in the middle of a round. That's why it's 4 to 5. In each act in this phase, we continue to update the congestion window because we want to make sure that the bottleneck remains full. And the growth factor here is basically a fraction of the congestion window as grown by standard slow start. So we have a growth divisor. This is another value that is worth experimenting with. And then for each round in CSS, we go back to detecting if the RTT is shrinking or not. So effectively, if the current min round RTT during any of these rounds, assuming at least n RTT samples, are less than the baseline that we snapshotted, we declare the exit as spurious and we resume high start plus plus, which means you go back to doing slow start, you go back to detecting whether there are delay spikes. You basically repeat the algorithm from the beginning, starting with the congestion window that you already have. If you determine that at the end of all these rounds that the RTT did not decrease, which means it has a sustained increase, then you enter the congestion avoidance phase. So this basically still gives us the benefit that we trigger slow start exit before there are massive packet losses. As before, the very first congestion signal, which could be loss or ECN, would trigger an immediate exit from slow start from this whole algorithm into congestion avoidance. We currently recommend that we do this only on the first slow start when the value of SS thresh is not known. And we also recommend that one implementation could use this after resuming the connection from idle. So some lab measurements here. So when there is no jitter, we compared the new high start algorithm with a TCP connection that runs no high start and the original high start. So I can explain a little bit what each of these test cases are. So basically 25 milliseconds, for example, for the first set of bars is the RTT of the link, 100 Mbps is the bandwidth, 312 packets is the bottleneck buffer size, 64,000 bytes is the IO size, and 500 is number of IOs. We're trying to effectively measure good put, which is also a sort of proxy for flow completion time. So what we find is that even with the new algorithm, the performance is really good. I think there's only like one test case where we found that it was worse compared to the original high start. So even with the changes to the algorithm, when there's no jitter in the network, we seem to be doing really well, and particularly doing really well compared to having no high start. In the presence of jitter. So in this case, the two parameters are added here. One is the 40 JIT MS. I'm talking about the very first set of bars again. 40 JIT MS is basically 40 milliseconds is the maximum jitter that we introduce for a given packet, and 20 JIT deviation means there's a 1 in 20 chance that a particular packet will experience jitter. So we basically introduce artificial jitter. These are lab measurements with an emulated bottleneck link. So here, as you can see, in the presence of jitter, the original high start algorithm does not do well. Particularly to note, it does worse than having no high start. But when you with the new algorithm, we do much better than the older algorithm. There is like a couple of test cases here where it's worse than not having high start, but in sum total, when you look at the previous slide where we had no jitter, it was doing pretty much well in all the cases compared to no high start. So we still believe that the default of having high start is still makes sense. The number of rounds, we did try varying it. So these are just some results from both jitter and non-jitter cases where you vary the number of rounds. So across all these test cases, we found that the 4 to 5 rounds number makes the most sense in terms of performance overall across these test cases. We did compare, and so the new high start here is basically for 4 to 5 rounds. We also modified it to run 2 to 3, 1 to 2, and 3 to 4. And across all these test results, the 4 to 5 rounds seems to give the best number, but this is still like something that implementations could experiment with. So this is basically how long you end up spending to determine if the exit was spurious or not. And I would like to mention that because we're still growing the congestion window, the performance will remain good. So we are erring on the side of still keeping performance good while we detect whether the exit was spurious or not. So we have made a rather significant change to the algorithm compared to draft 01. So we published draft 03, which is what this presentation is based on. We are currently flighting and doing real-world A/B measurements. We don't have the data to share at the moment, but we would be happy to share that with the working group as soon as we have that data. We would like to reevaluate the fixed RTT threshold clamps. Right now, they are 4 milliseconds and 16 milliseconds. Bob had a question about whether on the mailing list, whether these values could be determined as a function of the RTT. That's a little counterintuitive to me because the bottleneck buffer occupancy is not directly related to a given flow's RTT. So while we would like to make these dynamic, it's not clear to me that how we should go about doing that. Right now, based on lab results, we do find that going lower than 4 milliseconds introduces more noise. The 16 millisecond number is certainly worth revisiting, and we'd like the community's help to figure out how to make those thresholds more dynamic. And one question for the working group is, so currently this is on standards track based on previous discussion in the working group. One outstanding question I have for the group is, should we change the status to experimental because we are still making changes to the algorithm and improving it? So I would like to hear from both the chairs as well as the working group on what the intended status should be. And I think that concludes the presentation. So thank you.
Thank you for the presentation. Yeah, so the chairs want to know the opinion of the working group. So do some participants have an opinion whether experimental or proposed standard would be preferred? Yoshi?
Okay, can I speak? Okay, so one question I have is there are several tuning parameter like CSS growth divisor. And then, so while you are preparing draft, there might be a possibility that you might want to change the recommended value, right? Or you want to publish it, and then when you publish a new version, like as a proposed standard, you want to put a new value. Which was your intention?
No, I think like when we publish this, we would certainly recommend values for each of these constants. So everything is a trade-off here, right? For example, I would say actually that pretty much all the constants here, all the magic constants here have trade-offs inherent in them. For example, the divisor, it would determine how aggressive or not your congestion window growth is while you're determining whether the exit was spurious. So there is trade-off here in terms of performance versus being conservative. Similarly, how many rounds you spend for detecting if it was spurious also has trade-offs, right? So we would pick these values based on experimental results and real-world data, right? All of these are worth experimenting with. The values that we have currently put in the draft are a result of lab measurements. But the draft would also say that implementations can experiment with these values. So I guess my question to the community is like, whether it makes sense to publish this as experimental or like proposed standard. I don't know if I answered your question.
Mhm. Okay. So another question is, you said there might be an algorithm to dynamically find the parameters. And do you also explore the possibility in this draft?
No. So right now, yeah, the RTT threshold certainly not. I think that those constants are something that would be nice if they were dynamic. It's just unclear that a TCP could determine what that should be based on a given bottleneck buffer, because it's extremely difficult to measure the buffer occupancy and the bottleneck buffer size, because this is less a function of the connections RTT. It's more a function of detecting queue buildup at the bottleneck buffer. And that's where, like, we have a min clamp of 4 milliseconds to not be too noisy, like, trigger a lot of spurious exits, and 16 milliseconds as, a signal that buffer is building up. So I would like to know if, even LEDBAT, for example, and LEDBAT++ use like a fixed delay, target. So the question is, can we make that dynamic? I guess it equally applies to LEDBAT++. I think it's more a research question, and I would appreciate if folks have insights on that. What I would say, though, that with the values that we have measured, the algorithm is extremely effective. So based at least on data, even with these fixed thresholds, it seems to work really well in practice.
Thank you. Bob has a question.
Yeah.
Yep.
Go ahead, Bob.
Okay. I don't really have an opinion on experimental versus proposed standard, but I just wanted to clarify when I made the points about the RTT thresholds. It was really more, and it's relevant to this question of experimental or proposed standard. It was really more whether those, if you can write in the draft how you get to the numbers, that's probably more important than the numbers. You know what I mean? So what they are relative to other things and why you've chosen them and things like that. Then as the environment changes in the future, even if the RFC becomes outdated, people can still get information out of it as to what things should be, how things should be set.
That's fair, Bob. We would update draft with specific text about how we arrived at those constants and what the trade-offs are.
Yeah. Thanks.
Richard?
So I've been hearing a lot of discussion around constants, and now Bob also comes up with determining how these constants could be tuned to a specific environment. But overall, I think, or I would lean more to answer your original question toward experimental status at this point in time, as long as it's long as there is no well-defined environment where the HiStat++ should be using a certain set of recommended values for all of these things that you mentioned. Because ultimately, at the later stage, we still have a process to go from experimental to proposed standard, right?
Martin?
Yeah, as an individual, doing things with experimental does create problems when we try to incorporate this into other standards. I would say that if the working group, and of course the proponents, feel strongly that this is generally applicable, and that I don't want to say there are no downsides, but that that broadly we'd be comfortable to deploy it on just about every TCP host out there. That would have salutary effects for everyone. I think if we reach that level of confidence, I think we should make it a proposed standard.
Christian?
Yeah, I think that Praveen, you have to be proud of your work and just go for standard, because your work does fix a bug in the original high start. And so let's go for it. And if there's an issue that has to be fixed, well, then fix it, but go for it.
Michael? Charles?
Yeah, this is Michael speaking. First, I'd like to mention that there are a couple of +1 on standards track in the chat. So that is also something to be taken into account. Second, more the chair, I think we don't have to make that call right now. As we can keep the status as standards track for the time being and decide during working group last call whether we change our mind. We have done, I think, the similar thing in the other way around, but I think we could also do it this way. And that is, and this to me looks like a good approach for the time being. Try to work on it on standards track, and if you finally figure out during working group last call that it's still too much research, then we can decide at the end to downgrade to experimental. That would be my view.
Yeah, my point is that if you have parameters in your algorithm and the values depend on conditions or trade-offs, that's not a reason for me to go for experimental. So if you can lay out, this is the algorithm, these are the parameters, these are the rules, how you can deploy it safely or more aggressively, and then you have these consequences, that's for me okay to go for proposed standard. In an implementation, you would do it like syscontrol variables or socket options if you want to let the user decide which trade-offs are done in which way. So I would say keep it as it is, and when we go to working group last call, we look whether experimental or proposed standard is a better fit. As an individual. Any other comments? I have one question. So when you send packets, are you sending them in bursts, or are you putting some delay between them?
Right now, no, there is no pacing here. They will be sent out in bursts. There is a cap to the number of the amount of burst as a function of how the ABC limit is computed. So an ACK can only generate so much data in return. So that's the cap that sort of protects the burst size, at least in our implementation. But I see no reason why a paced implementation would not also benefit from this.
And what value of L2 are you using for this ABC thing?
Right now we use a value of 8, so
Okay.
that's the max growth, right?
Okay. Thank you. Any other questions?
Any reason why you use a value of 8 instead of 2 in the spec?
Yeah, so the spec said to historically the TCP implementation Windows used the value 4 because 2 was deemed as too limiting in terms for performance. Later, given the networks have changed to be faster, particularly switches and buffers, switches and routers have like larger buffers now. When we experimented with these values, 8 was found to be the sweet spot. Going any higher, for example, 16, was leading to much higher retransmissions and losses based on the data. That's how we arrived at the number 8. I would like to call out that that number is not specific to the High-Start++ algorithm. It's just a implementation choice in the Windows TCP.
Any other questions? If that's not the case, then thank you. And we move on to the next agenda item. Michael is going to present some work on the Tcpm model.
Okay, first, can you hear me? Yes, okay. So obviously, I'm giving this talk as individual contributor, and I'd like to give a brief update on the TCP Yang module. This is joint work with Vishal and in particular Mahesh, who is currently, I think, who might be in the IDR working group while I present that. So before we go into the details, let me briefly give a recap of what this draft is about. So this is a very small and well-focused Yang module for TCP configuration. It basically covers two different aspects. First, it more or less translates content of the TCP MIP into Yang semantics. That's basically basic statistics in the connection list. And second, it contains configuration parameters for TCP/OO and also MD5, simply because we have use cases for that specific configuration parameters. We were very careful in adding configuration parameters, so we only add to this Yang document configuration that's actually needed elsewhere in the IETF. And that use case at the moment is in particular the BGP Yang module. Also, this has caused some confusion in the last meeting, so therefore I added this once again on the slide. So there is in IDR a BGP Yang module that in particular needs TCP/AO configuration. And at the moment, the IDR model takes those definitions from the TCPM module. That's the main use case. The IDR model is a very complex Yang module, which the authors hope to finish by end of this year. And this also means that the corresponding definitions of TCP/AO should be stable by more or less end of this year, which is also the milestone for the document. We also use in the model keep alive configuration from a netconf document in case that keep alive configuration is needed, but that's just an import of something that's done in the other document on in netconf and TCP client server configuration. So this is just a recap of what this document is about. The document itself is one of the smallest Yang modules in the IETF, given the very narrow scope, so it fits on one slide. So as I mentioned, it basically includes a connection list, statistics, those are the equivalents to the TCP MIP, and then it includes for each connection in the list TCP/AO configuration, and a very simple statement for MD5 in case that's needed, and an import for keep alive. So it's a very easily readable document. As I said before, we explicitly focus it on a very narrow use case. So basically, it only includes statements for which there's a definite use case elsewhere in IETF documents. And this hopefully addresses the concerns that were raised earlier that this could boil the ocean. So as I said, it's probably one of the smallest Yang documents in the IETF right now. We've updated the document a couple of weeks ago. The current version is the 0.2 version, and we've addressed in the 0.2 version the comments that we got in the last meeting. Also, first of all, we reported in the last meeting some issues that we found during implementation. And we updated that, first of all, that required an improved description of the connection list. We struggle here a little bit with the Yang semantics, and we've updated the description in the Yang module basically to explicitly mention that what is meant by making the list as read-write. So this has some implications. And the key questions that we discussed last time were what happens if a netconf client creates a new entry in the TCP connection list, and also what happens if it deletes one. And we've added descriptions to the Yang module for those cases. Then we simplified the model by removing imports from the netconf model, which doesn't make a lot of sense there. So we discussed this last meeting. Then we also had a discussion during the last meeting about the reset RPC call that is in the Yang module. So there was a very helpful comment from Richard, and I think Michael Tixon, that it's not very complex to implement such a reset, and we've mentioned that trick basically now in the description and kept the RPC as it was before. And last but not least, is also something that I mentioned before. We improved the description of TCP modeling based on feedback from Nokia and Juniper. All in all, these are fairly minor changes. It's more about editorial additions, not the change of the actual model. I see Praveen in the queue. So Praveen, if you have any questions on those slides, please feel free to step up. Okay. The key open issue right now is that at the moment there's no implementation of that model, and we are trying to change that. So as reported that also during the last meeting, that we are working on a prototype for that Yang module. I work on that with 2 students who made progress on an implementation of that. So I'd like to give a brief update on what we've done since the last meeting. So we use a netconf server software, Clixon, which is an open source netconf implementation. That is pretty powerful, also relatively simple. It has one downside, namely that it doesn't support NMDA so far. So that's one of the issues. But other than that, it's a fairly straightforward netconf server implementation. It's relatively easy to use. We use that netconf server framework to implement the part of the model that can be implemented on a standard operation system right now. That's basically the connection list and the stats. What is missing right now is the TCP/AO configuration, simply because there's no open source TCP/AO implementation right now that we could use. We have tested that both on Linux as well as on QNX, and the latter as an example for an operating system that's more typical for embedded networking hardware. And we hope that we can open source the prototype relatively soonish after the meeting. It's still not fully finished, but once we have it, we plan to release it so that everybody can have a look at it and play with it. During these implementation efforts, there were no further issues identified in the Yang module. So, as I said, the parts that are supported by operating systems that we have access to work in the Yang module, and that they can be implemented. In the last 2 slides, I'd like to give a brief overview of how the implementation looks like as of today. first, this gives an overview of how a netconf server actually looks like. This might be a little bit an unusual diagram in Tcpm because we typically look at the protocol stack itself and not at a management software that's running on top of the TCP IP stack, but that's the typical management software that runs, for example, on a router or on an embedded networking device. It basically offers a couple of management interfaces to the external world, command line interface, netconf, or possibly resconf. And by the corresponding netconf or resconf interface, the system configuration can be changed via plugins. And what we are obviously doing in this work right now is to implement one such plugin for the Yang module that I've just presented. That is, we basically add a plugin to this netconf server that translates the netconf commands into commands towards the network stack, as for example, netstat commands or reading from the proc directory or whatever is needed on a specific operating system to retrieve the parameters of the TCP stack. Of course, this plugin is operating system specific, but the front end is operating system independent. So that's what we've done so far. As I said, also the parts that are available on the operating system, Linux and QNX, they have been implemented that way, and I hope that we can release the prototype as open source soonish so that everybody can have a look at this. And that's actually my last slide. The document gets more stable, but we still have some time to finish it. So that's why we obviously look for feedback from the community. And that's all from my side.
Thanks for the presentation, Mahesh.
The question, I guess this is for the chairs. Based on the fact that Michael presented, as a contributor, we seem to have resolved all the outstanding issues and also have an implementation that has not identified any more issues. I guess my question to the chairs is, what will it take to progress the draft to its last call?
That was actually the question I wanted to ask the authors. So what do you think needs, well, I mean, what do you want to do before you think this is ready for working group last call?
Yeah, at least from my side, I still plan to open source the software. So that's something that I think will hopefully increase the credibility of that. But once we've that, I'm not aware of further open issues. So if the other chairs agree, we could head towards working group last call.
So what do you think we gain from your implementation being open sourced?
Well, I mean, there's been pushback against this work in the past.
That's true, but I don't think this was because there was no open source implementation available.
Well, at least during the working group adoption, there were statements that the support of adoption is conditional to the fact that somebody tries to implement it. So at least we had statements like that during adoption. And I mean, I try my best to actually try to come up with an implementation with the limited resources that I have.
But for the document, you don't expect any changes?
At the moment, not.
And I mean, you have implemented this.
Yes.
I mean, you don't have you haven't implemented the AO stuff.
There's one open issue that's the availability of TCP AO as open source,
and that won't change.
That's not that might change actually. I've heard rumors that we might get within the next couple of months that there are open source activities, but I've not seen anything specific. So there are rumors that an open source implementation of TCPO might come up, but I haven't seen it so far. But if something in that space would show up, that would obviously allow to test the remaining part of the model.
Mahesh?
To unmute myself. Yeah, so the question is the fact, I think that Michael also asked, is would the fact that there is no open source implementation of TCP/AO going to be a gating factor to the publication of this draft? You know, I don't know what the guidelines are. The idea is, what I understand is from implementing the model is to make sure that there are no obvious issues. Right? Like if we don't have an implementation, can't validate it, I wonder what would happen to the status of the draft. Would we wait?
I mean, my personal opinion would be, I mean, I don't think it's a good idea to block this document until someone provides an open source implementation of AO. Yoshi?
From my point of view, yeah, we adopt this draft as a working group item. That means, you know, we agree to publish this document in a nutshell. And then, so if we want to stop it, I think I would like to see very explicit opinion that we should not do this, and with explicit reason. Other than that, no, I don't see any. We should not block this kind of thing.
So the question then for me is, shall we wait from the timeline or until the next IETF or something for making a working group last call? Just, I mean,
the alternative would be just to do the working group last call very soonish. I mean, there have also been comments in the past that it wastes working group time to discuss this document. The sooner we get it off the table, the less working group time is consumed. So that would be one argument to do a working group last call soonish. I mean, the big question is how much revenue it will get. So that's obviously.
But you will get the same revenue now or in 2 months or 3 months. So the point is, so from what I'm hearing is that, and I agree, it would be good if we can, if you can implement the AO stuff to make sure that's working. However, waiting for an implementation showing up, which we don't know if it shows up or not, I don't know if it makes sense to do that. So if that's the only thing you say would make sense to delay the working class call, I would, as an individual, I would say, let's go ahead. Mahesh?
So 2 things I just wanted to point out. One is kind of obvious that, of course, the last call would have to be made on the mailing list anyway, whether it's discussed in the meeting or not. It has to be verified on the mailing list. The second point that I think there is going to be a misref, even if we do go ahead with publication. So it's not like it'll go and get published, because there is a dependency on the netconf module that we are importing. And I know that we are trying to push that in netconf to its publication also. So I'm hoping that they kind of line up at the same time.
So does it make sense to send these documents at the same time to the ISG?
Sure, we can definitely try to coordinate. I can let you know when we are ready to push the button on the netconf draft so that, and you can push the TCPM about the same time.
So that would make sense to me. I mean, we don't have the netconf documents are also more complex than that one. So I mean, we don't have to wait forever on them. But yes, as it could make sense to sync those documents.
Do you expect changes to the TCPM document based on changes in the other one?
We import the keep alive groupings.
Right, but I think the question is, do we expect any change? No, I think it's fairly stable, at least on the netconf side. So.
Okay. Okay, so we will discuss this and
Okay, fair
determine
enough.
how to progress.
Let's discuss it afterwards.
Any other comments? Technical comments? If not, then thank you for the presentation. And Bob is next on accurate ECN.
All right.
Michael, can you stop presenting? Yep. Bob, you can go ahead.
All right. Okay. Everyone see that? Okay, this is about more accurate ECN feedback in TCP. Latest draft 15. It's a very quick recap. Essentially, there's a 3-bit field using the header flags that were previously used for ECN, or it overloads them. And there's also an optional option to supplement them. That's for those who haven't joined this group before. Now, where we are with this on implementation and testing, ILPO has kept the implementation up to date with the Linux kernel, although the Linux kernel has gone a bit forward from this, but he's kept it up to date with the latest one that supports BBR or BBR, so because he wanted to make sure accurate ECN could work with all the congestion control modules, which it now does. So the great thing about that is that you can now do like testing of different congestion controls with the same feedback, so you're not changing 2 things at once, which is a very useful feature of it. And it also means it proves it works with the more traditional congestion controls, the Reno, the Cubic, and so on, which it essentially provides a superset of by giving all the congestion information you get from ECN, and then just giving those particular congestion controls the 1 indication per round trip time that they need. And just to mention, there's also Richard's FreeBSD implementation, which is getting a bit out of date now, and doesn't include the TCP option. But it's would be good if someone wanted to build on that. That would be great in FreeBSD. So now we have been spending a lot of time, and we means myself and ILPO, mostly ILPO, definitely mostly ILPO, testing accurate ECN with different levels of ACK filtering, and that testing is ongoing. I'd also like to ask if anyone here would has the resources to be able to, some of the larger companies to do more wide area testing. And I think you need both actually, testbed and wide area, because wide area you find the oddities that you need to explain, and testbed you get more understanding of what's going on. And so on the testbed, I give results below, which I'll go into comparing 4 different degrees of feedback support that Accurate ECN provides. But the reason you can get more understanding is that obviously you can repeat your traffic scenarios and what AKMs you have and things, but also you can, by building the models of the ACK filters, you get a lot better understanding of what you do if you just tweak those models, because you've got to also bear in mind that new ACK filters might come along, and so you want to sort of try and stress it beyond what the current ones are. I should add, on AQMs, we've tested it with both on-off AQMs and ones that space ECN markings more, because that gives very different challenges for ACK filtering, and found some interesting possibilities, like the possibility of synchronization between an ACK filter and the round trip time, where you've got blocks of on and then blocks of off in round trip time chunks. Tends to get you different results. So that work's ongoing. The ACK filters, we've used some quite aggressive ones. It says they're up to 1 in 34 packets, which is actually 1 in 1 ACK every 4 milliseconds per flow, and ones that are not really particularly TCP smart, that are fairly just dumb decimation things. Been based on that, building heuristics into Accurate ECN to deal with all the possibilities. So just a quick summary of what all the tests are and what all the results are. The tests on the left, there's with the optional options, the supplementary options, which gives you effectively ground truth. It's as good as you get without the ACK filtering. Or going down that column, we have a minimum option, which is not always putting an Accurate ECN option on, just trying to conserve resources, because if there's minimal space, using the rules in the draft. And then there's no options at all. All of those, of course, have the 3-bit ACE field as well, because that's in the TCP header. And then we also have another case for interest to compare. If we had DC TCP feedback instead, we've implemented that for testing as a switch in the code. So without really Accurate ECN ACE at all, just using the 1 bit in the header, but still with the negotiation around it. So results generally, with any amount of options, it's nearly as good as you get without ACK filtering, even with extreme filtering. With no option at all, and just the ACE field, it's usually good, but sometimes we do get poor results. But that was actually before we've put in any really serious heuristics, other than very simple cases like assume the worst wrap and assume the best wrap of the 3-bit field. And on the DC TCP case, it's sometimes good, but it's reasonably unpredictable. We'll post some results to the list as we get them. But moving on, just to repeat a slide that I gave last time, and so I'm not intending to go into everything on this slide, other than just the table in the middle. So this was about the possibility of ACKs having CE markings on them, and then this rule saying you acknowledge every N CE marks would mean you may end up acknowledging an ACK or ACKing an ACK. And so this table states where we came to on the list, where originally the recommendation was every 2 data packet, sorry, not every 2 data packets, every 2 data packets with a CE mark on. And now, if you come to a packet with a CE mark, and you've got to 2 CE marks, and it's not a data packet, you don't emit an ACK. You have to wait until you've had 3, and as the recommended value, but up to 6, but no less than 3, so you don't get this ping pong, or you damp out the ping pong very quickly. And the other point that Yoshi raised about that on detecting duplicate ACKs, we've now put all the text in the draft about that, so if people can review that, that would be useful. And it's essentially what was agreed on the list, that if you want to test for a or when you're testing for a duplicate ACK, if SAC has been negotiated and there's no SAC on it, don't treat it as a duplicate ACK. Or if you're not using SAC, I think SAC's the easiest test, but you can use timestamps and just check that the ACK wasn't sent before your oldest unacked data. And finally, if you don't implement that test, you should not send ECN-capable pure ACKs in the first place. So that's all in the draft. Please review it. Then Neil had a question about whether, if you've got a run of packets come in a burst in GRO or LRO, do you have to follow those rules as you're going through the burst? And that was really just a bit of ambiguity in the way that thing was written. It was meant to be when you process the burst, you then decide what ACKs to send. And so the guideline is that you should still send every N, but if it's performance critical, if it could harm your performance, you don't have to. And I noticed it's very similar to the rules that are in the quick draft as well, on the similar subject. So I think that's all been on the list and fairly simple. We have also fairly radically altered the rules on when you send the TCP option. Not really changed the code much. It's just that it wasn't clear that the main rule was meant to be send send a TCP option on every packet that acknowledges new data, and particularly only use this is a change, only use the 2 fields or the number of fields that have ever changed in the connection, so don't waste time repeating a field that has never changed. And so making that the top level recommendation, and then the other recommendations are sort of cutting back from that if you need some space for, say, SAC options or something, what you do about that. And we've removed some of the more complex requirements on beaconing fields, and there was one that hadn't realized was still in there that should have taken out ages ago, about emitting an ACK whenever any byte counter changes. So that section has got quite a bit of diff text in it and would be useful to review, please. And so the final slide, there's been a lot of text tweaking as well. Thanks, Gori. More changes around the middle boxes and distinction between normalizers and transparency. Also, not in the draft yet, but I've got it ready to post tomorrow. A look through of the draft from the eyes of someone who wanted to do a minimal implementation, say for a limited, resource constrained device or something, because there's talk of using, jumping to this for thread or IoT devices. Just checking that if you did implement all the musts and nothing else, that it all made sense. And in doing that, noticed some of the wording around some of the musts. There were some duplicates and things like that, so tidied that up a bit. So ready for working group last call, except we're waiting for, well, we've had a security directorate review, but I think the idea was that we were going to get another one, so sort of still waiting for that. And I don't suppose that holds up a working group, that's cool. But the other thing that's going on is obviously the ACT filter testing. And just to point out that the generalized DCN draft that's not being presented today, it's sitting there. It's not, it's ready, but it depends on this draft. So that's why it's sitting there, and no need to present it because it's just ready. Okay, that's it. Any questions?
Thanks for the presentation. Praveen?
Yeah, my question is about the ECN marking of PureAx. In the ECN plus draft, it says that the implementation has a choice here whether to even have PureAx be ECN marked. My understanding is today acts don't count towards congestion control. So what is the benefit of making PureAx ECN capable? And if we just had a requirement that implementations don't make PureAx ECN capable, then we wouldn't have to deal with all this complexity of for detecting duplicate acts.
Right. This draft doesn't require you to have ECN capable acts, but the whole way that the draft has been written is that it has to deal with anything that comes in. It's what a receiver does, and so if PureAx become the thing in the future, ECN capable PureAx become the thing, it's got to be able to deal with them. So it just says what a receiver does if it gets one of those sort of acts, and so we have to put all the machinery in case those acts come in, and indeed slightly more than that, because of the generalized ECN draft recommending that you put ECN on acts, then that's and it's something that a number of people want to do. So I detected a slight willingness to or need for care on the complexity of that. If you put ECN on PureAx, it doesn't mean you have to do anything about them. Obviously, it protects them from getting lost, but it does mean you do have a better idea of congestion on the ACT stream if you need it. And so in future, just unilaterally, if you like, a asymmetric data sender could then see what congestion was coming in back to it on the ACT stream, and it could, if there was something like Carles Gomez's, ACT control thing, it could then ask the receiver to thin the ACT stream. But that's all. It's just there because you've got these acts coming in and they might be ECN capable, so you've got to be able to deal with that anyway in your code, because it's a possibility in the headers, so you have to do something about it anyway. Does that answer the question?
Yes, it answered the question, Bob. Just one follow-up. So what happens if the receiver does not send an ACT back in response of marked PureAx?
No, nothing happens. This is only actually it says must emit an ACT once NC marks have arrived since the previous ACT. Yeah, so it's a must, but if the implementation doesn't comply with it, and obviously even if it does, the ACT can get lost, nothing happens. It's no acts get lost and no one knows they get lost now. It's not the sky's not going to fall.
Good, John.
So since we're on this slide, I might as well just ask my first question on this slide is when we said must emit an ACT once NC mark have arrived. So in the world of like a GRO, let's say you receive the TCP receive a jumbo packet, right? After GRO of say 16 MTU size packet, and they all have CE marks. So does that consider n equals 16 or n is equal to 1? Is that one C mark or 16 packet worth of C mark?
Well, this is what this slide said, that you deal with that. You take in the super segment and then count everything up. That would be considered to be NC marks, but there is this get out clause at the end that if you haven't got the resources to send an ACK every N packets, you don't have to. However, as I understand it from the answer Neil gave on the list to this question that I asked, DCTCP does, when it goes through one of those super segments, it does send out a whole load of ACKs back to back to keep to its rules of how many, of marking or of ACKing every 2 CE marks, or ACKing any transitions from or to CE and not CE. So you just get this bunch of ACKs coming out, as Neil understands it anyway.
Okay, that's not my understanding of what the Linux DCTCP does. It doesn't send a bunch of ACKs or like purposely send extra ACKs just to create more sort of CE ACKs.
Right. Okay. Well, I mean, Neil said it did, but maybe you could correct him or talk with each other and see which is the right answer, because I'd be interested to know. But the point of this one is of accurate ECN is you don't have to, and also it's sort of less critical that you do, because you're sending a counter. So if you for a start, you haven't got to send every 2. N isn't 2; it's 6, and so you've got more scope for not sending so many ACKs. And obviously, if you're sending the option as well, you don't even need to worry about wraps in that 3-bit counter, because the option's got 24 bits. So it's, so you only send 1 and you get the full information.
Okay. We can resolve more offline. My second question is to that comparison study, with the minimum option, and also there is the DCTCP FB. May I ask what does FB stands for in that DCTCP?
Oh, that's just DCTCP feedback. That's just saying it's not a DCTCP congestion control. It's just the feedback part of DCTCP.
Oh, okay. I saw it's Facebook DCTCP implementation.
No.
Something like that. But for the no option, you mentioned some poor scenarios. Would there be some tech report published so we can see like more details of what are those poor scenarios?
Yeah. Certainly, we want to make sure that we do it all properly. Yeah, and as I mentioned in the when I gave the slide where wide area testing is also needed, if you guys wanted to do a bit of testing of this as well, we've got the code now that you can switch in DCTCP feedback or and compare things and all the rest of it, and compare different congestion controllers. So it's all in Linux.
Okay.
Right, in 5.10.
Okay. So you mean this poor scenario are already documented in the current draft, or there will be
No, they're not. No, and probably given the difficulties of putting graphs in ASCII, we would do that in some separate technical report and then refer to it. Yeah.
Okay. And what's the minimum option part?
That's yeah, I tried to explain that, but I glossed over it maybe. There are rules in the draft as to what's recommended for how often you put an option on packets, and the recommendation is you put an option on every ACK that acknowledges new data, and then it says if you haven't got space for some reason, you've got to follow these rules, and it gives some rules as to what best to do, and that's so that minimum option is following those rules without putting on every ACK. It's what the minimum rules are, and then no opt is no options at all.
I see. So in your opinion, if we replace the DC TCP inside the data center with the accurate ECN with the no option route,
Yeah.
do you foresee like big issues coming up? Like this will
Well,
cause migration.
I don't see. I mean, okay. I need to ask you. I assume you haven't got uncontrolled ACK filters in your data centers.
In fact, that's also my question. What exactly is an ACK filter?
Oh well, you know, like Wi-Fi, for instance, or you know that coalesces a load of ACKs, or DOCSIS that takes out, you know, per flow each time it does a request grant every 4 milliseconds or 2 milliseconds. It only sends one ACK for each flow, rather than, and so it coalesces up all the ACKs.
ACK coalescing has happened naturally because of GRO. So it's extremely common to see an ACK of ACKing 64 kilobytes. Very common, and it's actually going to be bigger if you see Eric's presentation in the last NetDev called Big TCP. Yeah, we are going to see basically high ACK compression, but not through the typical DOCSIS mechanism, but just naturally happen with GRO.
Yeah. So I mean, I would say that if you get, once you go to really high ACK coalescing, filtering, whatever suppression you want to call it, then I would suggest you're putting the option on the packets, because this 3-bit counter is just going to become a bit sort of, you know, it's going to spin around multiple times if you get 100% marking, you know. So it's but you know, we have developed and we are developing heuristics to try and work out what that counter might mean, even though it wraps. But I don't know, I've heard numbers of 44 that might cope with that, but getting higher than that, you know, I think you need, I see this as the 3-bit field is really just a stopgap to get the thing deployed, but eventually it's going to need the option to get through. But until the option gets through, you know, something. You know.
I see. Okay, cool. Thank you. Yeah.
Go on.
Hi, Richard.
So I just wanted to go back to the question of Praveen around the X for X again. So one area where this could be relevant, and I believe we have discussed this, is when you have a data stream or when you have a session where the data flow is changing direction on a regular basis, however infrequently enough that you may get close to the idle period. So using that mechanism with the X still delivering fresh CE information, you can keep the say in the data center TCP the alpha value up to date. And the other comment I wanted to make on this is that that was a discussion that we've had around the IoT space. A sender is not required as of yet to have the pure X marked as ECT capable, ECN capable. So meaning the quote problem unquote of X to CE marked X, which in turn may be CE marked, may not be all that of a big issue if one or the other side of a data transmission do not mark the pure X as ECN capable in the first place. So that was just a clarification. I hope that this further clarifies where this comes in. But it really is what Bob explained. The draft should be making sure that the receiver's behavior, the receiver reflection of received CEs are quite good, well defined, so that the sender can rely on those feedbacks. Hope that makes sense.
Thank you.
Michael?
Just realised I haven't got my video on.
Yeah, I have a question, not so much to Bob, but more to the rest of the group. So when we started this work, I recall that there was pretty strong pushback against the option from implementers specifically. And now, if I read the slides correctly, we have a should in there, and that the option should be used relatively frequently. As far as I understand, that's a change as compared to what we did 2 to 3 years ago, for example. And my question more to the group is if actually the opinion in the group has changed, that the egg using the option in some cases, for example, because of egg filtering, doesn't do harm.
Okay. Before people answer that, can I just clarify that the draft says if you're going to use the option, you should use it on every packet by default, but if not, you could, these are the rules for how you don't. So it's only if you are using it.
Yeah, sure, but still, you basically the recommendation gets stronger than before.
I would say the recommendation is stronger because of ACK filtering. Because I mean, this draft has been around long enough that when it first started, there wasn't really much. You know, there was a bit, but it was nothing like as aggressive as it is nowadays.
Yes, I said this question was more to the group than
to
Bob.
Richard is the next in the queue.
So to answer that question, I still believe that for constrained environments, so basically those that Yucheng had in mind, not using the option is quite viable, and I believe the data that we've collected so far also shows that, because one aspect that may be glossed over here a little bit is that most of these extreme scenarios assume long continuous runs of CE marked packets, and that is not necessarily the case depending on what kind of EQM is deployed, right? So for example, the steady state mechanism for data center TCP or data center TCP's feedback loop with the CE marking on a switch is typically only 2 marks per RTT, meaning you don't tend to get overly excessive runs of packets, all of them CE marked. So the recommendation obviously has to cater for this in the draft, but I believe that many environments exist where you can get sufficiently accurate feedback without the option nevertheless.
I think the option itself is not the problem. It's really the compatibility with GRO and TSO, or generally segment offload. And I think the trend is just that as the NIC speed get pushed higher and higher, right? It's growing so quickly. We are trying to batch even bigger aggregations. That's what the big TCP is about. The 64 kilobyte aggregation is already running tight on saving CPU cycles. So really, how ACE is, or accurate ECN is compatible to the GRO and TSO is really the key question. And I haven't reviewed the latest doc, so I cannot say it does not do well or not.
And I think we need to have a bit of time together to talk about that specifically, but also having the ability to compare it with DCTCP is useful, and I guess the biggest point here really is that ECN itself is the problem against GSO and GRO and all the rest of it, because it's inherently all about changing from ones to noughts, which is something that offload finds difficult. having everything changing all the time, rather than being the same, or changing in a way that has significance that you have to pick up.
Praveen?
I had a comment on this option support. So I think within the data center, this is reasonable, but on the internet, we typically see middle box issues. The last time we tried to roll out a new option, we saw all kinds of interesting middle box behavior with TFO. So I guess the question is, is there any experiments that have been done at internet scale to see what kind of bad middle box behaviors would occur as a result of rolling such an option out, and whether the draft should address any sort of like strategy for an endpoint to deal with bad middle box behavior? I guess that would be the challenge for implementers.
I will tell you, this draft would be a few pages if it wasn't for all the stuff in there about having to deal with middle boxes and all the tests for doing it.
And by the way, that's correct. Also, the draft discusses middle boxes quite a bit, so that's well covered.
Yeah, all the complexity in this is about falling back if you get different middle box problems. If it wasn't for that, the draft would be simple.
Okay, I think this answers my question, and it was more to the group than to Bob. So thanks a lot.
Praveen, do you still want to say something, or?
I was going to say that it's not just about a single connection. Like, we've seen pathological behavior where one connection's attempt to use an option resulted in problems for subsequent connections. So that's the main concern. So within a connection, how to deal with this gracefully makes a lot of sense.
Yeah, I think we definitely need to move into that sort of phase of testing this now, at larger scale. And any, if you want to help with that, Praveen, that would be great. Okay.
More questions? Comments? If not, then thanks for the presentation and the discussion. Next is an update on Cubic by Vidi.
Hi, can you hear me? I'm trying to see which audio is going to work the best for me. Okay, cool. All right, do you have the slides?
You can present them by your own.
Oh, okay.
Yeah, no, I mean, you can click on this where your name is on the top left. There is a document thing, I guess, next to your hand.
Ask to share slides.
Yes, and
is that what
we
it
can
is?
approve that, and then you can control them by yours. Oh.
Okay, this is my first time doing it this way. So
yeah, it's the first time. This is the first IETF where they have this feature.
Cool. Wow, that's cool. So, hi everyone. As some of you might already know, we have been making some changes to the Cubic RFC to adapt to the recent advancements in transport protocols. And we are planning to publish this updated draft as a proposed standard and thus obsoleting the informational RFC 8312. A quick recap of the things that we discussed in the last IETF. So we have updated the definition of K to use a new state variable condition window start, which is basically the condition window at the start of condition avoidance. The cubic increase function requires certain safety guards for the lower and upper bound. The lower bound is to make sure that we are not decreasing the condition window during avoidance, and the upper bound is to make sure that the growth is not more than what it is for slow start. And these upper bounds and lower bounds are already implemented in Linux. For the AIMD window that Cubic uses for low BDP environments, the time-based approach doesn't seem to work well with certain rate-limited senders, as the congestion will continue to grow even when the app is not sending a lot of data. So we have changed this in the revised draft to just do whatever new Reno does, based on the ACK clocking and the bytes acknowledged or the segments acknowledged. Because we made this change, we thought it would be good to make another change, basically, where when the congestion window has reached the previous WMAX, we would set the alpha to 1 so that we can probe for the new WMAX, which is similar to what new Reno does. Other changes include a new section for spurious losses, and here we define what an implementation should do before doing the congestion window reduction and what it should do after detecting that the previous loss event was rather spurious. And as some developers also refer to the Cubic research paper for the pseudocode, we have highlighted the differences between the research paper and the internet draft for better understanding. There were a lot of good feedback. There was a lot of good feedback and comments, and thanks to Yoshi and Michael and others who reviewed the draft thoroughly and provided great comments. And we have updated these changes in the latest release draft, which was, I think, published, which was, I think, out there on last Monday. So please take a look at it. I will give a brief summary of the recent changes from the last IETF. The original RFC was written based on a paper published in 2008, and thus the general theme was that Cubic is an extension of traditional TCP standards. But this has changed over the years, right? And it kind of is obsolete to say Cubic is an extension, so we have changed the text to make it sound like Cubic has become the most deployed congestion control over the internet. So, and we have updated the draft so that it sounds like, oh, this is today's reality, and doesn't sound like it's a draft from 2008. And we have also updated the text to say that this can be used for transport protocols such as QUIC and SCTP. There was another confusion that Yoshi pointed out. Most of these issues were pointed out by Yoshi, so thank you, Yoshi, again for doing the thorough review. There was a confusion about the alpha AIMD and beta AIMD, and they seem to be used for different things in the draft, and that was causing the confusion. So we have removed both of these, and instead we just use alpha and beta for the generic average AIMD equation. And we have introduced alpha cubic to refer to the additive increase factor used specifically for cubic. It's editorial, but it kind of makes the reading of the draft much more smoother. All the variables and the equations in the draft are based on the segments of MSS size, but some implementations use bytes. So we have added guidance for implementations to be able to use bytes acknowledged if that's preferable. And additionally, as segments ACT need to be MSS sized, we have clarified that this number is a decimal value. And it can also be, less than 1 when you receive ACTs for packets less than MSS bytes. For the AIMD friendly equation, we have added clarification about appropriate byte counting so that implementations can adjust it based on the acknowledged bytes. And we have also clarified the delayed ACT scenario explicitly. Excuse me. In addition to packet loss detected by dupacks and ECE signals, we have added loss events detected by RACTLP and quick loss detection mechanism, which are common in today's implementations of TCP and QUIC. Last but not the least, Yoshi found a very interesting interpretation of convex region. The original text says cubic is very careful in convex region and increases the window very slowly at the beginning, which is true if the convex region starts right after the congestion window is greater than W max. But there is a possibility that convex region starts much later than as shown in the diagram. So in this diagram, if you see right after we reach W max, the AIMD friendly window is being used because it's higher than the increase by the cubic curve or the convex region. But only after a point, the convex profile takes over. So this means that when the convex profile takes over, it's not really that slow. So we have explicitly added a statement saying, unless it is overridden by AIMD window increase, cubic is careful in the convex region. There are more editorial changes, so feel free to take a look and let us know if everything looks good or if we messed up anything. We have addressed all the last call comments so far, and the latest draft, which is version 3, was published on Monday. If you have more comments, please send them to the mailing list. And if there are no further comments, we request the chairs to conclude work group last call and proceed with the next step. That's all I have for today. Thank you very much.
Thanks for the presentation. One reason for this presentation was to draw the attention of the working group to this document before concluding the working group last call to make sure that there are no late comments. Are there any comments right now? Praveen.
Yeah, I have a question actually. So compared to the original RFC and the this RFC as an implementation that makes these changes, do you expect to see any sort of performance differences as a result of implementing the BIS RFC, or do you expect that the algorithm's behavior with respect to performance characteristics is going to be pretty much unchanged?
Very good question. So the answer is yes and no. No, because Linux already has all of these things, and it's kind of learned what we learned from these implementations. We have described them in the draft. So for Linux, probably no. For other implementations, especially for Quick, there would be performance benefits if you missed out or if you followed the old cubic RFC word to word. So you will see performance benefits. And I think there were some updates perhaps from Quiche developers, or I might be remembering it wrong, but you will see the performance benefits if you follow the current the current draft as compared to the cubic RFC for new implementations.
Yeah, the only one comment on that is it might be useful to point out which are those actual differences that end up being performance benefits for implementations to pick up the BIS RFC instead of the original one.
Okay, like in the draft itself or over the mailing list?
Mailing list should be okay, I think.
Okay. Okay, if you can start a thread, then I can respond to that.
Mm-hmm.
Thank you.
Yucheng?
I just want to reflect the part about the ABC. So for the Linux implementation, Linux does not do ABC in a way that strictly ABC. So in Linux, either cubic or new Reno or any congestion control, when we receive an ACK that acts, 100 MTU size packet, say it's in slow start, literally the CWIN will grow by 100 MTU size worth of CWIN packet. So it does not increase the packet up to only 2 packet. And I think it's similar to the question I asked Praveen early on. Did you use 2 or did you use A? because the fact is that ACK filtering is everywhere and ACK aggregation is continue to go up and up, right? The stretch ACK, but
Right.
because that's needed for high-speed networking. So I want to ask if we still want to stick with like, okay, Cubic should use the ABC standard, which is not really what a very common implementation use, or we should trying to change that part to reflect what the code is actually doing today.
Yeah, that's a good point. I think so. Right now, we currently, maybe you can look at the draft, but right now we say that the equation that we use is when ABC is disabled. And if you enable ABC, then this should be adjusted for acknowledged bytes, which means really like, I mean, what is ABC? ABC doesn't mean that you always have to use 2, L equals to 2. You use your bytes acknowledged, but you have to put a maximum limit. And that's not a must. If I remember ABC correctly, that's kind of a should for the times, when people were acknowledging 2 segments at a time. And definitely that has changed to multiple segments per ACK. So still using the number of bytes acknowledged, the first, the main theme of ABC is you count the bytes. Still makes sense, right? Even if you don't follow the L equals to 2.
Yeah, I think it's the cap that I'm talking about. So I don't know if we want to put an wording on the cap may not necessarily be sort of pragmatic anymore. But yeah, just want to throw this out.
Right. I think then the ABC draft everywhere it's referred is going to have that problem. So maybe, I don't know, it's time to update the ABC draft because of the cap.
Yeah, that's another
the idea is good. Yeah, the idea of ABC is the right idea, that you count the bytes. It's just the cap wasn't recommended based on the what is in practice right now.
Yeah, I agree. Thanks.
Yep. Thank you.
Richard?
Around the ABC. So if I remember it correctly, at least in the stack that I know, ABC is during slow start mostly used to prevent X-splitting attacks. And I believe you go up to twice the number of acknowledged bytes per ACK as a maximum. So that doesn't necessarily mean 2 MTU-sized packets, so it can even be higher than that. But obviously that's implementation specific. Just a side comment, not specific to.
Thank you. Thank you, Richard.
So RFC, what is it? 3, 4, 6, 5 says TCP implementations may use L equals 2 and must not use L larger than 2 times MSS. So
yeah, okay.
So for the document, but it's informational. And there were plans to update it.
Yeah, thank you for
there are still
double checking.
plans to update this, but I guess Martin comes in for that. So you want to address that, Martin?
Yeah, so 3465 is experimental, and 5681 has ABC boil limit of 1, and that is actually the standard that allows byte counting. Because of high start for a while, we were talking about making 3465 the standard. That seems to have fallen. That seems to have dropped. But with 5681 having the concept, that's fine. If the working group thinks that guidance is just obsolete, at the risk of scope creep, we could roll that into this. If just the consensus is like the internet is run with no actual limit on ABC for a long time, and it's working fine, it hasn't collapsed. I don't know, just something to consider.
I think maybe it's time to look at if we should update ABC about that cap. It's because we indeed find performance issue with Cubic with that, ABC cap. That's why we actually patch up the Linux Cubic to deal with all the stretch check issues.
Yeah. I mean, there shouldn't be any cap specified. I think this should be left to the implementation because anything you put in there is not going to work in the future. It may be too high or it may be too low. So, and maybe
So Yi Cheng, are you advocating to have this draft update 3465?
Now,
I support that.
Yeah, with the discussion, I think, since so many RFC cite that as the most straightforward is just to update that draft.
Yeah,
and it's not a big change anyways.
Yeah, and I would like to add another thing just because we're talking about it. I think the whole pacing thing is missing from that. So stretch act can be used to increase the congestion window, but then that, if not used with pacing, could cause a lot of bursts. So if your stretch act is increasing the window by 100 packets, for example, then I think the OS needs to do some sort of pacing.
Praveen?
Yes, I agree. That's a great point to have. Yeah, it's pros and cons. We should both document both well. Yeah.
Yeah, and ABC is a good draft for that. All these things together, I think, for an update. ABC is actually a perfect draft for that.
Yeah, I would agree that we should possibly update ABC, not really have this draft talk about changing ABC. I think updating ABC makes more sense. Because, for example, even the high start draft that I presented earlier today refers to ABC.
Any more comments?
Well, just the only thing. So if there's energy to do this, that's great. I will say that having communicated with Mark Allman a few times, and he's the author of 3465, that if somebody like would write a draft 00, that would probably move the ball along a lot faster than Mark will. So I don't think we should. I think we should involve him, but I don't think we should wait for him to make the first move.
Okay. Yeah. Perhaps one of us could reach out. And I think I did reach out to him at one point of time. I was thinking about ABC, and I don't remember where that thread went. But looking at all these developments in congestion control algorithms, like high start, cubic, and getting them proposed as a proposed standard, then we should update all the references, especially that relates to byte counting. Yep, we can start a thread. I can. I don't want to make this promise, but I'll try to start a thread on this.
Yoshi?
Yeah, I just clarify one thing. Even though we are thinking about updating ABC, this should not block this draft, right? This draft is already almost conclude working with Blastable, so it's almost there. So we don't have to wait until ABC is published, I guess.
They say ship it, regardless of the status of 3465. Currently, it's an informative. So 3465 is an informative reference to the cubic draft, which I have not spent a lot of time thinking about, but seems a little odd to me. If it were to become normative, then we would be blocked in RFC ed forever, which is not ideal. But just a question of what you think you can credibly claim in terms of whether or not it's normative or informative.
Yep, I agree. We should not block this draft on updating ABC, or any other draft for that matter. iStar++ too.
Any other comments?
So to reiterate, the short path here, 5681 has byte counting, but with a 1 MSS limit. So in terms of normative informative, like that is a safe place to go to just get the concept of byte counting. And I don't see any advantage in referencing 3465, which gives the two packet limit, which is not actually any better, or well, it's better, but it's not sufficient. So you know, if you need to do it normatively, just use 5681, and then I think you're safe.
Are you suggesting, so let me just double check. Are you suggesting to remove ABC reference and use 5681?
So I have to do some more thinking about whether or not it needs to be an normative reference. And if it is a normative reference and you map it to an experimental, then you are stuck in the RFC editor until 3465 gets updated. Which, or there's some there's more bureaucracy, to put it one way. 5681 is of course a standard, and I guess my point is that if you're just looking for a reference to the concept of byte counting, it exists in a standard, which is 5681. The only reason to reference 3465 normatively is to get the 2 packet limit, which doesn't seem all that useful to me.
Mm-hmm. Okay.
Sorry, this is all like process stuff, but I guess that's what I'm here for.
Yeah, I mean, the process stuff also has to be taken care of because it's part of the process. So Yushi, are you thinking it's okay to remove the ABC mention that we have added to the draft based on a recent comment, or what do you think is the best way to move?
Yeah, I think it's okay to remove it if you want, but I think cubic can work without ABC, and then so that means it doesn't have to be normative reference. You can put in a informational reference. That's one way. Okay.
So I have to check if it's normative reference. I think it is, but we'll put an informational reference to make progress. Thank you.
Lars?
Yeah, Yoshi said what I was going to say, that I think 3465 is informatively referenced pretty much by many TCP standards because of that. And I don't see a reason to normatively reference it here either.
Yeah, so I just double checked. So thanks, Lars. It's currently is informative, so I don't think we need any change. So the draft that was published and that it's currently an informative reference.
Any other comments? Okay, then thank you.
Thank you.
Looking at the co-chairs, do you have anything else to discuss? We have 7 minutes left. Anyone else wants to bring something up which is not on the agenda? Okay, then thank you very much for the meeting and see you at the next IETF in some way. Bye.
Thanks a lot. Bye.